Good day, everybody. Welcome to my channel. So today we're going to be doing application of differentiation, rate of change to be precise. So what exactly does rate mean? In calculus, you are usually familiar with the sign dy by dx, or the 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 p by the x, or the z by the x, or the whatever by dx. So the difference between this and rate is that whenever you hear the term rate, it always means with respect to time. So whenever you're given a question and you're asked to calculate rate, you know that you're calculating the rate of change of some function or some variable with respect to a parameter, and that parameter is time. The difference between the rate and the gradient is that rate, you are calculating change with respect to time, and gradient, you are calculating change with respect to another variable or parameter that is not time. For instance, let's say we have something like y equals 2x plus 6, right? And we differentiate this function, we're going to have dy by dx is equal to 2 from your normal differentiation. The difference between this dy by dx and dy by dt, where dt is change in time, is that this dy by dx is calculating the rate of change of y, which is a variable, changing with respect to x, another variable that is not time. But when we have something like dy by dt, this is y changing with respect to a variable or parameter, which is what? Time. So that's basically the difference between rate and gradient. So whenever you have something like dy by dq, dy by dw, dy by whatever that is not time, that change is actually called a gradient or a slope change. But if you have something like this variable changes with respect to time, or calculate the rate of this variable's change, blah blah blah, you are dealing with that variable changing with respect to time. That's basically the whole concept of rate of change. So we're going to take some practice questions now. Practice question goes thus. It says the radius of a circle is increasing at a rate. Remember, that means this radius is increasing with respect to time at a rate of 0.01 centimeter per second. That means per second of time, the radius is increasing by 0.01 centimeter. That means 1 second, 0.01 centimeter, the second, 0.01 centimeter, and so on indefinitely. It then says, find the rate at which the area is increasing when the radius is 5 centimeters. All right, I'll take it again. The radius of a circle is increasing at the rate of 0.01 centimeter per second. Find the rate at which the area is increasing when the radius is 5 centimeters. So the first thing we need to do is to write out like the information that we provided. So it says the radius of a circle is increasing at a rate of 0.01 centimeter per second. That's to tell you that this is basically the rate of change of the radius, and we can write that as dr by dt, because it's calculating how much the radius is changing with respect to a change in time. From the information provided, we know that our radius, or the rate of change of the radius, is 0.01 centimeter per second, right? It then says find the rate at which the area is increasing when the radius is 5 centimeter per second, 5 centimeter. Now, before we go there, this one, remember we've established that the r by the t, or the rate of change of the radius, is 0.01 centimeter. Now, this is positive. Why? Because it says increasing. Assuming it said decreasing, it would have been negative, but since it's increasing, so we use positive. So let's go to the second part. It then said find the rate at which the area is increasing when the radius is 5 centimeter. So we're looking for what? The change in area with respect to change in time, since it says rate. So we're looking for what? The a by the t. This is unknown. It then says when the radius is 5 centimeter, so our r is 5 centimeter. We've done the first step. So the second step now is to establish our formulas. We know that, or remember that, the a by the t is equal to the a by the r times the r by the t. Why? The reason is so the r's will cancel and we'll be able to get our the a by the t value. So a simple way to remember this formula is not actually to cram it, but it's to remember that whenever you have something like let's draw a line. Have something like you're looking for, let's say, the x by the t, right? Let's say you're looking for the value of this depending on the context of the question. Instead of memorizing this formula, just remember that the x will always be changing to a variable, then multiply by that variable's change with respect to time. To just know that the x or the whatever that variable, this is depending on the question, and the t, they are constant, they must always be present in the formula. Then whatever is here is called this beta and beta, they must be the same, and you also get them from the context of the question. In this case now, what these variables are is radius, because we have the a by the r times the r by the t. This is the variables that these are the variable, or this is the variable that concerns the context of this question. I don't know if you understand that. Just remember that, for instance, in this question now, you know that we have the a by the t. So we know the a by the t is going to equal the a by the r times the r by the t, such that the r's will cancel. If we're looking for the x by the t, and let's just say we know we have something like the x by the alpha, where alpha is another variable in the question, times the alpha by the t, such that the alpha will cancel. Let's take another example. Let's say we're looking for something like dy by the t. We know that this is going to be dy by the alpha, where the alpha is another variable in the question, times the alpha by the t. I hope you understand the pattern. So that's basically just the pattern. So we can also infer from this now, or rather we can now proceed from this. So we know that the a by the t is the a by the r times the r by the t, because we know that our the a and the r are with respect to the context of this question, because we have our area and we have the radius. So that's why we're using the a and the r here. If it was another question that gave you the volume and the side, it would be what? The a by the s times the s by the t, where the s is the side and the v, not the a, is the volume. So that's just basically, you use this formula will always be respect to the context of the question. Let me give another example to make it more clearer. So let's say we are given the volume of a shape, and we're now given this radius of that same shape. I will ask to find the rate of change of the volume of that shape. You know, it's obviously going to be dv by dt, since we're calculating the rate of change of the volume with respect to time. That's just going to be what? Dv by the r, the radius, that's the rate of change. The rate of change on the volume with respect to the change in radius multiplied by the r by the t. You can see the pattern similar to this. So that's basically how you go about it. So now let's go back to this question. So we know that our the r by the t is equal to 0.01 centimeter per second, right? And we know that the a by the t, that's the rate of change of the area, is equal to the a by the r times the r by the t, right? If we infer, we can see that the r by the t, we already have it, and that's 0.01, right? So how do we get our the a by the r? Very simple. We know that the area of a circle is what? Pi r squared, right? So what do we do to get our dA by the r? This dA by the r basically means the rate of change, or the area, the change of the area with respect to change of radius. And we know that we have pi r squared here. So if we differentiate both sides with respect to radius, we'll have dA by the r. Why? Because pi is a constant. So the only variable we can differentiate a with respect to is obviously r. So our dA by the r is just going to be what? Differentiate. 2 comes to the back, pi r 2 minus 1. So our dA by the r is equal to 2 pi. So we have 2 pi r. And we know that our dr by dt is equal to 0.01 centimeter per second. And the radius is 4 centimeters. So we already established that our dA by dt is equal to dA by dr times dr by dt. So we already have our dA by dr here, and have our dr by dt. So we can just plug in our values. So dA by dt is equal to dA by dr is 2 pi r, 2 pi r times dr by dt 0.01, right? So remember that our r also equals to 4 centimeter at that change. So we know that dA by dt is equal to 2 pi times 4 times 0.01. Do we get? So know that our dA by the t is equal to 8 pi times 0.01 centimeter. So our dA by dt is equal to 8 times pi is just 3.142 approximately, then times 0.01. So our dA by dt, just plug in this into your calculator, and that says the volume of a sphere is increasing at a constant rate of 12.8 pi centimeter cube per second. Find the radius of the sphere at the instant when the radius is increasing at a rate of 0.5 centimeter per second. I go again. The volume of a sphere is increasing at a constant rate of 12.8 pi centimeter cube. Find the radius of the sphere at the instant when the radius is increasing at a rate of 0.5 centimeter squared. So in this question, we are looking for r, not actually the rate of anything. So the first thing we need to do is write out the provided information. So the first provided information is the volume of a sphere is increasing at a constant rate. That means this is our dV by dt, the change in volume with respect to change in time. So let's write it out. Our dV by dt is equal to 12.8 pi centimeter cube per second. In essence, find the radius of the sphere at the instant when the radius is increasing at a rate of 0.5 centimeter per second. That means this is our dr by dt, or the change in radius with respect to a change in time. So the second info is dr by dt is equal to 0.5 centimeter per second. So we're basically looking for the radius of the sphere at the instant when the radius is increasing at the rate of, right? So what we need to do now is to establish the volume of the sphere. The formula for the volume of a sphere is 4 over 3 pi r cube, right? This is the formula for the volume of the sphere. And remember from the previous question that dv by dt, or the any variable by dt, is equal to dv by dr. That's the rate of change of the volume with respect to the change, or to a change in its radius, multiplied by dr by dt. So just know this pattern. It's always going to be dv by the something times that something by dt, or the something by the something times this by dt. So just understand this. This is basically the pattern where your v and r can be anything, but just remember that this dt is constant. So since you already know that, or since we established this, dv by dt is equal to dv by dr times dr by dt. So we have our dr by dt. So the problem is already getting solved. So we know that dv by dt is equal to dv by dr times dr by dt is 0.5. So how do we get our dv by dr? Very simple. Since you know that this is the volume of the sphere, so we just differentiate this with respect to r. That's basically what this is asking us to do. Dv by dr. That's find the change in volume with respect to change in radius. So what do? We differentiate this with respect to r. So if we differentiate volume with respect to r, we'll have what? Our dv by the r is going to equal 3 times 4 over 3 pi r raised by 3 minus 1. And that's just going to be dv by dr is going to be 3 cancels 3. We have 4 pi r squared. So our dv by dr is 4 pi r squared. So we can now plug this into this value. Yeah. So we have dv by dt is equal to 4 pi r squared times 0.5. And if we remember, we established our dv by dt to be 12.8 pi centimeter cube per second. That's provided in the question. So the question says the volume of a sphere is increasing at a constant rate. So this is the change in volume with respect to change in time. That's 12.8. So we can just substitute that for here. So we have 12.8 pi equals 4. No need to add the units yet. 4 pi r squared times 0.5. So let's simplify. Let's divide both sides by 0.5, 0.5. This cancels this. So we have 4 pi r squared is equal to 12.8 pi divided by 0.5. Okay, so we have 12.8 pi divided by 0.5. So first of all, let's just simplify. Let's just divide both sides by pi. So pi cancels pi, pi cancels pi. So we have 4 r squared is equal to 12.8 divided by 0.5 r. So that's 12.8 divided by 0.5. Yeah, so we have 4r squared is equal to 25.6, right? So let's divide both sides by 4. 4 cancels 4. So we have 25.6 divided by 4. So we have r squared is equal to 6.4. So what do? We take the square root of both sides. So square root cancels square. So r equals square root of 6.4. Let me just add that to my calculator. Square root of 6.4. That's r equals plus or minus 2.53 approximately. But since radius cannot be negative, we just choose positive value. So our radius is equal to 2. Okay, the final question. It says find the rate at which the volume of a spherical balloon is increasing if the surface area is increasing at the rate of 5 centimeters squared per second when the spherical balloon's radius is 4 centimeters. I take it again. Find the rate at which the volume of a spherical balloon is increasing if the surface area is increasing at the rate of 5 centimeters squared per second when the spherical balloon's radius is 4 centimeters. So let's write out the information we have. So we know we are looking for dv by dt, right? The rates of change of the spherical balloon. So we know we're looking for dv by dt, that's unknown. And we know we have if the surface area is increasing at the rate of 5 centimeters squared per second. So we know we have our dA by dt, that's the change in area with respect to change in time. So we know we have our dA by dt to equal 5 centimeters squared per second. And they said when the spherical balloon's radius is 4 centimeters, so our r is equal to 4 centimeters. So from the previous questions, we already established that dv by dt is going to be what? Dv by the r times the r by dt. No, remember I said dv and the r can be anything while the t remains constant, such that the dr and the r or whatever change here and whatever change here will cancel each other. So remember dv and the r, they can be anything. Just remember this pattern. So that's what will help you to solve any question under this topic. So we do not have our dr by the t, so we can easily get our dv by the r. And we can also get our dr by the t from the a by the t. Why? Because we have a value for that. We do not have a value for this. If not, we would have been able to find this. In fact, that is this value we're even looking for. So let's go back to our friend dA by dt. So we also know that dA by dt, following this pattern, will be what? dA by dr times dr by dt. So how do we get our dA by dr? We already have our dA by dt, that's 5 centimeters per second, right? So we're looking for our dA by dr. So how do we get our dA by dr? First, what is the area of a sphere? So the area of a sphere is equal to 4 pi r squared. So how do we get our dA by dr? We differentiate this with respect to r. You get, so our dA by the r is just going to be 4 comes to the back. It's going to be 8 pi r, 2 minus 1. That's why I have 1 here. So let's plug this back here. So now our dA by dt is equal to dA by the r is 8 pi r. But remember, I said our r is 4. So we can just plug in our 4. Then multiplied by dr by dt. We don't know what that is. So dr by dt. Also remember that our dA by the r is 5 centimeters squared per second. So we can just use 5. Let's ignore the unit for now. So we have 5 is equal to 8 pi 4 times dr by dt. So what do? We divide both sides by 8 by 4. Divided by 8 by 4. So this cancels this. So our dr by dt is just 5 over 8 times 4, that's 32 pi. So dr by dt is just going to be 5 divided by 32 times 3.142. So dr by dt is just 32 times 3.142, 32 times 3.142. That's just going to be 5 over 100.544. So the r by the t is just going to be 5 divided by 1. Sorry, let me just plug out my calculator. 100.544. So our rate of change is, or our dr by dt is 0.0497. So now we have our dr by dt, so we can now find our dv by dt. So remember, dv by dt is equal to dv by dr, that's change in volume with respect to change in radius, multiplied by our di by dt, 0.0497. So how do we get our dv by dr? Simple. What's the volume of a sphere? The volume of a sphere is equal to 4 over 3 pi r cubed. So how do we get dv by dr? We differentiate it with respect to radius. So we have dv by dr is equal to 3 comes to the back, 3 times 4 over 3 pi r 3 minus 1. 3 cancels 3. So our dv by dr is equal to 4 pi r squared. Now a simple trick is, if you have the volume of a shape and you differentiate it, you get the area, and you differentiate it again, you get the circumference. So a quick tip is that whenever you are probably in the exam hall and you cannot remember the formula for one measuration of a shape, and you remember one, so let's say you have remember the volume. If you differentiate the volume, you get the area. Differentiate the area, you get the circumference. That's just like a quick trick. So we have our dv by dr, so we can now plug that into the formula. So dv by dt is equal to 4 pi r squared times 0.0497. And our r is 4 centimeters, so we just have this is equal to 4 pi times 16 times 0.0497, right? So dv by dt is just going to be 64 pi times 0.0497. So you can just plug this into your calculator, and that's the final answer. Thank you for watching.